Hello friends, now we will discuss a very small topic of MOSFET, that is comparison of different type of MOSFETs, enhancement and depletion, N channel and P channel, and finally comparison of MOSFET with BJT. This topic is important for engineering services prelims exam, and there can be 1 mark question in GATE also. The first topic is, this is just theoretical topic, so I'll be giving you points one by one. All those points you need to remember and mark up. First is a comparison of enhancement and depletion type of MOSFET. If you recall, in case of enhancement and depletion type MOSFET, there is a one basic difference. In enhancement type of MOSFET, the channel in the gate is channel between the drain and source is formed only when we apply the gate voltage. If you recall that their characteristic, this is VGS, this is drain current ID. In case of enhancement type MOSFET, it varies like this. So the current is almost zero below threshold voltage, but whereas in case of your depletion type of MOSFET, drain current exists even when gate to source voltage is negative, that is pinch off voltage. So when it is not zero, even then gate current will be existing. That is one basic difference. So channel, in case of enhancement, channel will be formed only when voltage is applied at the gate terminal. It is not the case in case of depletion type. The current exists even when gate voltage is zero. That is what the basic difference. Number 2, your enhancement type MOSFET always works only in enhancement mode when VGS is positive, whereas depletion type MOSFET works in depletion mode when VGS is negative and in enhancement mode when VGS is positive. So depletion type MOSFET can work in both modes, enhancement and depletion type, depletion mode, and enhancement can work only in enhancement mode of operation. Then logic level is totally different. In case of MOS enhancement, we always have positive voltage. In case of depletion, for variation in conductivity of the channel, we need to have negative voltage at the gate. So voltages required will be different, positive and negative, whereas in case of enhancement type, we only need to have positive voltages. So that is the basic logic level difference between the voltages. In case of depletion, I need to have positive as well as negative voltage, whereas in case of enhancement, we need to have positive voltages only. So these are the basic difference. In case of enhancement type MOSFET, when it is off, there is always possibility of one current which is known as sub-threshold current. So sub-threshold current is existing in enhancement, but there is no sub-threshold current in case of depletion type. So there is no problem of sub-threshold current in case of depletion type MOSFET, and there is problem of sub-threshold current. Sub-threshold current cannot be eliminated in case of enhancement type MOSFET. So these are some of the differences. You can listen to my video again and again and remember these points. There can be question on it. Then second is N channel and P channel MOSFET. Very first difference is electrons have higher mobility than holes. So basic difference between enhancement in N channel and P channel is that difference between the electrical behavior of electrons and holes. Holes are having less mobility, electrons are having more mobility. Advantages: when because of higher mobility of electrons, you will find N channel MOSFET is preferred. Reason: because of higher mobility, their frequency response, they will respond fast. Electrons will respond fast. So frequency response of N channel MOSFET is better than P channel. That is first point. Second, because of higher mobility, the conductivity of, or you can say resistivity or resistance or conductivity of N channel MOSFET will be more as compared to P channel, or we can say drain resistance of channel resistance of P type MOSFET will be more as compared to N type, right? Then the other differences like your packing density of P channel MOSFET will be less, packing density of N channel MOSFET will be more. Physical size of N channel MOSFET is less as compared to P channel, physical size I am saying. Then switching speed of N channel MOSFET is more I told frequency response is better, then switching speed of N channel MOSFET is more as compared to P channel. Why? Because electrons can respond faster. So these are some basic differences which you need to remember. But in case of N channel MOSFET, there is a problem. When your oxide layer has positive charges trapped in it, remember, oxide layer always has some positive charges trapped into it. Those positive charges attract electrons from the substrate to the channel. So there is problem of premature turning on of the N channel MOSFET. Why? Because if you have MOSFET here, this is dielectric, this is N layer, this is N layer, so positive charges stored here will attract the electrons, so because of which there is formation of the channel even before the threshold voltage. So your current may start from flowing from drain to source, that is known as premature turning on. So there is problem of premature turning on in case of N channel MOSFET. So these are some of the points you should then we have discussed physical size, packet density, then frequency response, resistance. So these are some of the points you need to remember. Then third one is the comparison of MOSFET and BJT. This is again very important as far as your engineering services prelims is concerned. There are a lot of questions on comparison of BJT and MOSFET. 8 to 10 points I'll be considering one by one. First, MOSFET carries current because of one type of carriers, so that is known as majority carriers. So current in MOSFET is because of majority carriers, whereas current in BJT is because of both minority and majority carriers. Due to this reason, BJT is bipolar device, whereas MOSFET is unipolar device because it carries only one type of carriers in the channel. So MOSFET is unipolar device, BJT is bipolar device, number one. Number two, drain current in MOSFET is controlled by gate voltage, whereas collector current, remember, collector of the BJT is similar to drain in MOSFET, base of the BJT is similar to gate of the MOSFET, then emitter of BJT is dual or similar to your source of the MOSFET. This is duality between these two, right? So the drain current of MOSFET is function of the gate voltage, whereas collector current of BJT is function of base current. So what I mean to say is, BJT is a current control device, whereas MOSFET is a voltage control device. So that is second difference, right? Then third, your BJT suffers from a breakdown at collector junction. Collector junction is reverse bias and complete collector current flows through that reverse bias junction. So we always keep larger size of the collector region so that there is sufficient heat dissipation from the collector. So that there is no thermal breakdown at the collector junction, but there is no such type of problem in MOSFET. Even though there are reverse bias junction, but that current, that level of biasing is not that much as compared to BJT. So MOSFET does not suffer from any thermal breakdown. Reason being, because when collector junction is reverse bias, if temperature of the collector junction increases, there is generation of electron hole pairs, and that results into reduction in resistance at the collector region, and there is increase in the collector current. And that finally result increase in collector current further increases heat at the collector junction, there is further increase in temperature, there is more generation of electron hole pairs, and the effect becomes cumulative, finally resulting to thermal breakdown at the collector junction, which leads to a thermal damage, which is known as secondary breakdown. Whereas in case of MOSFET has positive temperature coefficient, its resistance increases with increase in temperature. So when temperature is increased, resistance increases. When resistance increases, the current will decrease. When current decreases, heat generated will decrease, so temperature will decrease. So MOSFET itself will take care of that. So because of the positive temperature coefficient, there is no problem of thermal runaway. That breakdown is called thermal runaway in BJT. So MOSFET does not suffer from thermal runaway. That is your third point. Fourth point is, in case of MOSFET, we have the minority carriers stored in the base region. during the switching behavior, during the switching transient, that minority carriers are required to be removed. But in case of MOSFET, there is no storage of the carriers in the channel. So there is the switching, you can say the switching time, that is turn off time or recovery time, reverse recovery time in MOSFET is very small as compared to BJT. So switching speed, that is switching speed of MOSFET is very high as compared to MOSFET. Sorry, I'm repeating, that is wrong, I said it wrongly. Therefore switching speed of MOSFET is very high as compared to BJT. Then other points you should remember, in case of MOSFET, when you talk about parallel operation, the MOSFET is compatible with parallel operation. Why compatible for parallel operation? Let us take one example. I have two MOSFETs connected in parallel. One is like this. These are two MOSFETs connected in parallel like this. And let us take case of two BJTs connected in parallel like this. So what happens in case of BJT? Suppose temperature of this BJT is increased. If temperature of this BJT is increased, current, then resistance of this BJT will decrease, current in this will increase. Increase in current results into further increase in heat, generated heat here, that will result into increase in temperature, and increase in temperature results into further decrease in resistance, and current will increase, and finally it leads to breakdown. But here there is positive temperature coefficient in case of MOSFET. When current in this increases, resistance of this will increase and current will further decrease. So the resistance of the MOSFET itself take care. When current try to increase, the temperature will increase, but the temperature results into increase in resistance, and that will result into decrease in current again. Able for parallel operation, whereas BJT is not. Then BJT is less noisy as compared, your MOSFET is less noisy as compared to BJT. That is related to transit time factor and all. I am not discussing that into detail. Just remember, MOSFETs are less noisy as compared to BJT. Voltage requirement of MOSFET is less. Voltage requirement of BJT is comparatively more. Then offset voltage. Your BJT has a higher offset voltage as compared to MOSFET. So these are some of points you should remember. Yes, high input impedance. I'm sorry, I have not shown that oxide layer. The input impedance of MOSFET is very high as compared to input impedance of BJT. Right? The input impedance of MOSFET is much greater than the input impedance of BJT. That is what you need to remember. But there are certain points. In case of MOSFET, the gain bandwidth product is smaller as compared to BJT. Gain bandwidth product is small. Then MOSFET has higher on state losses, meaning when MOSFET is on, continuously on, the resistance offered by MOSFET is more than the resistance offered by BJT when it is continuously on. So continuous conduction losses are more in MOSFET and less in BJT. But whereas switching losses means when you are using the device as a switch, the switching losses are more in BJT, less in MOSFET. Why so? Because in case of MOSFET, that switching reverse recovery time is very small, and that reverse recovery voltage is small. So because of that, the losses are less during switching transient. So continuous conduction losses are more in MOSFET, but switching losses are less in MOSFET as compared to BJT. So please do remember small points, but very important as far as engineering services prelims is concerned. There are a lot of questions in engineering services from these topics. Fine. Whatever I am speaking, you can note down in your copy, and I promise you will find questions from this. Rest there are again maybe one or two topics in MOSFET which are left again from engineering services point of view. Just wait for my next video. Thank you very much for watching the video.